I really want to make sure that you understand the concept of the derivative as the tangent line. Like, really get this idea. So we have a quadratic function on the right, g of x. So our first step is to find g prime of -4 and explain what this value represents in terms of the graph of the function. So the first thing I need to do is take the derivative. Well, I can't take the derivative of that unless we do some rearranging. So g of x equals 1/2 of x plus 2 squared. So that means I can rewrite it as 1/2 of, well, that would be x squared plus 4x plus 4 minus 4. And if you don't remember how I got that, that's x plus 2 times x plus 2. Distribute the 1/2. So I have 1/2 x squared. Half of 4x is 2x. Half of 4 is 2. And I get 1/2 x squared plus 2x minus 2. Now, when I take the derivative, I'm going to use power rule. So 2 times 1/2 is going to be 1x plus 2. So now it said to find g prime of -4. Well, that's -4 plus 2, which is -2. What does this mean in terms of the graph? Well, g prime of -4 equals -2 means that the slope of the tangent line when x is -4 will be -2. And does that make sense? Well, if we go here, if I draw in a tangent line here, will it have a slope of -2? Well, yeah, it does. The next one is find the equation of the tangent line drawn. Oh, now it says to sketch it. I already did that. Oops. Okay, so the equation would be, well, I need another point there, so we need another point of tangency, which I can tell from my graph is -4, comma, -2. Slope of tangency is -2. So y minus the y value equals -2 times x plus 4. You could even write this as y equals -2 x plus 4 minus 2. Or you could distribute it. That'd be -8 minus 2, which is -10. Any of those would be acceptable. Using the equation of the tangent line, find the value of y when x is -3.9. So, y equals -2 times -3.9 minus 10. It'd actually be easier to plug it in there, but I already started this, so that's 7.8, which would be -2.2. So this is kind of like an approximation of what the y value would be when the x value is -3.9. Now let's find out what the real value is. So I'm going to plug -3.9 into the original function. So we had 1/2 of negative 3.9 plus 2 squared minus 4. So I'm going back to the original function. And that would be, I'm not going to do that by hand. Okay, so that's 1/2 or 0.5, negative 3.9 plus 2 squared minus 4. So the actual y value is negative 2.195. What do you notice about these two values? Well, they're really, really, really close. So the equation of the tangent line can be used to approximate, how do we want to word that? Function values of, or at x values very close to the point of tangency. And I want you to really think about why I have to say very close to the point of tangency. Would this line help us make good approximations of x values over here? No. But anything really, really close to negative 4, this tangent line could really help us make some good approximations. So if I flip over, we have a new g of x. Based on the graph, at what value does the graph of g of x have a horizontal tangent? Well, it looks like we have a horizontal tangent right here. So g of x has a horizontal tangent at x equals 1, because it looks like we have a maximum there, because there is a relative maximum at the point 1, 3. Or at least it looks like that. How can I double check? Well, I'd have a horizontal tangent line if g prime equals 0. So I need to find g prime. So let's bring g down here. And I'm going to rewrite g so that I can use power rule. I don't like square root of x. I'm going to rename that as x to the 1/2. That's x plus 2. So the derivative, power rule, 2 times 1/2 is 1. Subtract 1 from the exponent. And this is going to be minus 1. Constant would go to 0. And I want to know when that equals 0. Well, let's rewrite it a little bit. This is going to be 1 over x to the 1/2, which is the square root of x. Add 1. So 1 over the square root of x equals 1. Well, that only happens when x is 1. And I can prove that. If I plug in 1, that's 1. So since g prime of 1 equals 0, there is a horizontal tangent at x equals 1. At what intervals is g prime less than 0? Well, that would be when we're decreasing. So g prime of x is less than 0 when g of x is decreasing. So on the interval from 1 to infinity. Or you could say x is greater than 1 if you wanted to. When is g prime positive? Well, when we're increasing. And that's a really short place. So g prime of x is greater than 0 on 0 to 1 because g of x is increasing. For what values of x is the slope of the tangent line equal to 2? So that means the slope of the tangent line. Anytime you see those words, think the derivative. So when the derivative equals 2. So we'd already found the derivative. It's 1 over the square root of x minus 1. And I want to know when that equals 2. So when I add 1 over, I get 1 over the square root of x equals 3. Turn that into a fraction so I can cross multiply. Love it. So if I cross multiply, I get 3 square root of x equals 1, or square root of x equals 1/3. Square both sides, x equals 1/9. Find an equation of the tangent line drawn to the graph of g when x equals 4. So I need my point of tangency, which I can get from my graph. That's 4, 2. I need my slope of tangency. That's going to be g prime of 4, which g prime was 1 over the square root of x minus 1. That's 1/2 minus 1. It's going to be a negative 1/2. So I've got my slope of tangency and I have my point. So y minus 2 equals negative 1/2 x minus 4. Or negative 1/2 x distribute, then add 2. And the reason I'm putting it into slope-intercept form is so that we can graph it on the grid above. So my y-intercept's at 4, and the slope is negative 1 over 2. Oh, it actually did go straight through that point, didn't it? So here is my tangent line when x is 4. Next example actually uses a table. Table of values below represent values of the graph of the derivative h prime. The zeros indicated in the table are only zeros of the graph of h prime. So I want to kind of think about what's happening here. So since this is the derivative, I'm going to mark when it's 0, because that's important. This way, we get 11 and 5, so that means that h prime is greater than 0. Here, it's negative, so h prime is less than 0. Oh, And here it's less than 0 as well. On what intervals is h of x increasing or decreasing? So, h of x is increasing when h prime of x is greater than 0, which occurs on what interval? So when h prime is greater than 0, that's in this interval. So let's look at the x values that make this happen. It's going to be all the x's less than -2. So you could put x is less than -2 or negative infinity to -2. And we already put our reasoning in. It's because h prime is greater than 0. Now h of x is decreasing when h prime is less than 0. Which occurs on here to here, and then from 7 on. Where does h of x have a relative max? H of x has a relative max when h prime changes from, so just a reminder, max would be like that, so from positive to negative, which occurs when x is positive to negative, when x is -2. When do we have a relative minimum? So h of x has a relative minimum when h prime changes from negative to positive, which never occurs. If h of 3 equals 2, what is the equation of the tangent line to the graph of h of x at x equals 3? So my point of tangency is 3, 2. My slope of tangency, since I'm given the table of the derivative values, I can find from this table. So when x is 3, my derivative is -3. So the equation of the tangent line is going to be y minus 2 x minus 3. And I'm fine with you leaving it that way. Now for the normal line, because it also asks us to find the equation of the normal line, the point of tangency is the same, but the slope is perpendicular. So it's going to be the negative reciprocal, so it's going to be 1/3. So y minus 2, positive 1/3, x minus 3. Find the tangent line approximation of h of 3.1. So tangent line approximation means I'm going to use this equation and plug in 3.1 and think about if this is going to be greater or less than the actual value. So y minus 2 equals -3 times 3.1 minus 3. That's 0.1. Negative 0.3. When I add 2 over, I get 1.7. Now I want to think about if this value is going to be greater or less than the real value. And it said that we were concave up at that point. So let's think also about 3. So we're decreasing and concave up. So decreasing and concave up means the graph is going to do something like this. So my tangent line is going to go underneath. So would anything on that line be greater or less than the actual value? Since h of x is concave up, the approximation is less than the actual value. Find the value of each of the following limits. Ooh. What happens as x approaches negative infinity? Okay, so going that way. Well, 0, 5, 11. It's increasing, so if my graph is... Oh, so we have to really think about this, huh? If my graph is increasing, right then, that means it's come from the bottom and it's going up. So if I'm increasing, that means I came from negative infinity. Now on the right hand side, my graph is decreasing, which means if I keep following it, I'm going to go back down to negative infinity.